closest. Okay, today we're going to be creating a line plot using data collected from a class who brought in Hershey bars to eat. The data shows the portion of their candy bar that they ate. In looking at this data, I see that the greatest number these fractions have in common of a denominator will be a 12. So I need to go through and change all of these into having denominators of 12. Sarah already has 2 twelfths, Delana 4 twelfths, Ansley, hers needs to have a denominator of 12. So 1 times 4 will give me 12. 3. So 1 times 3 equals 3. 3 twelfths is an equivalent fraction of 1/4. Isabella has a fraction of 2/6, which would be 6 times 2 equals 12, so 2 times 2 equals 4. 4 twelfths. Sammy already has a denominator of 12, so does Abby. Sarah Jane's needs to be converted, and it would be 9 twelfths. Lauren's also needs to be converted. It would be 8 twelfths. Kinsley's is 4 twelfths. Maddie's needs to be converted. It is 2 twelfths. Jordan's also needs to be converted. It is 3 twelfths. Angela's needs to be converted. It will be 4 twelfths. Chelsea's should be 3 twelfths. Mackenzie's should be 4 twelfths. Sally's is 1/2, which is the same thing as 6 twelfths. Noelle's already has a denominator of 12. Jada's needs to be 3 twelfths. Faith's has a denominator of 12. Elvira's needs to be 3 twelfths. Mackenzie's is 3 twelfths. Katie's is 11 twelfths. Grace has a fraction of 1/12. Okay, now that they all have the same denominator, we can go back and plot these fractions on our number line. So our number line will be broken up into 12 equal sections. We have 0 to 1 whole. This 1 whole represents having 12 out of 12 pieces. Okay, I'm going to split this in half, which would be 6 twelfths. And then I'll split this section in half, which will be 3 twelfths. I'll split this section in half, which is 9 twelfths. This will be 1 twelfth, 2 twelfths, 4 twelfths, 5 twelfths, 5 Okay, now we're going to take our set of data and plot it on the line plot. So our first set of data is Sarah. Hers is 2 twelfths. I'm going to put an X above 2 twelfths. Delana is 4 twelfths. Ansley, 3 twelfths. Isabella, 4 twelfths. Sammy, 8 twelfths. Abby, 6 twelfths. Sarah Jane, 9 twelfths. Lauren, 8 twelfths. Kinsley, 4 twelfths. Maddie, 2 twelfths. Jordan, 3 twelfths. Angela, 4 twelfths. Chelsea, 3 twelfths. Mackenzie, 4 twelfths. Sally, 6 twelfths. Noelle, 8 twelfths. Jada, 3 twelfths. Faith, 7 twelfths. Elvira, 3 twelfths. Mackenzie, 3 twelfths. Katie, 11 twelfths. And Grace, 1 twelfth. So we can easily look at this line plot and see that most of the students ate 3 twelfths of their Hershey bar. Now we're going to answer some questions about these. It says, how many students ate 8 twelfths of their candy bar? So I'm going to go over to 8 twelfths and count the number of students represented there by an X. 1, 2, 3. So 3 students. number 2 says, how many students ate 1/2 of their candy bar? So I do not see 1/2 listed as a fraction on my line plot, but I know that I can find the equivalent fraction of 1/2 that will have a denominator of 12. So what do I do to get from 2 to 12? I multiply by 6. 1 times 6 is 6/12. So I'm going to find 6/12 on my line plot, and I know that this is the same thing as having 1/2. And I'll count the number of students represented there by an X. 1, 2 students. Question 3 says, how many more students ate 1/4 of their candy bar than those who ate 4/12? Well, I don't see 1/4 on my line plot, so I'm going to find the equivalent fraction of 1/4. I'm looking for an equivalent fraction that has a denominator of 12. So what do I do to get from 4 to 12? I multiply by 3. So I am looking for the fraction 3/12, and I see that 1, 2, 3, 4, 5, 6 students ate 1/4 of their candy bar. Now I'm going to go over to the 4/12 category, and I see that 1, 2, 3, 4, 5 students ate 4/12 of theirs. So it says how many more? I will subtract 6 minus 4 to find out that 1 more student ate 1/4 of their candy bar than those who ate 4/12 of their candy bar. Question 4 says, did more students eat 8/12 of their candy bar or 1/6? Well, I don't see 1/6 on my fraction line plot, so I'm going to find the equivalent fraction of 1/6. I'm looking for an equivalent fraction that has a denominator of 12. What do I do to get from 6 to 12? I multiply by 2, so I do the same thing to the top. So I'm looking for 2/12. So for 8/12, I see that 3 people ate 8/12, and I see that 2 people ate 2/12 of their candy bar. So it looks like more people ate 8/12 of their candy bar. Okay, and the last one asks, if you were to add up the total number of Hershey candy bars eaten by Miss Hammond's class, how much would it be in all? So we're going to add each category plotted on our graph and then add those answers all together. So our first category is 1/12. Only one person ate 1/12 of their candy bar, so that one's easy. It's 1/12. The second one, you have 2/12 plus 2/12. That one's probably easy enough that we could do in our head because we know 2/12 plus 2/12 is 4/12. But I will write that out for you just to be sure you know what we're doing. 2 plus 2 is 4, and you keep the same denominator. So this one is 4/12. The next one is 3/12. I have 1, 2, 3, 4, 5. I have 6 of those. Now I could add 3/12 plus 3/12 plus 3/12 plus 3/12 plus 3/12 plus 3/12. But that's a lot of adding to do, when I could do something much more simple and just multiply them. So I'm going to take 3/12 and multiply it by 6 times because 6 people have eaten 3/12 of their Hershey bar. Now I know it's easier to multiply a fraction by a fraction, so I'm going to take this whole number and turn it into fraction form. 3 times 6 is 18, and 12 times 1 is 12. I need to turn this into a mixed number. So 18 divided by 12. 1 times 12 is 12, and I have 6 left over out of 12. So this fraction would be 1 whole and 6/12. Our next category is 4/12. Again, I'm going to multiply 4/12 and 1, 2, 3, 4, 5 by 5 students. It's easier to multiply a fraction by a fraction. So I'm going to put a line underneath this. 4 times 5 is 20. 12 times 1 is 12. That's an improper fraction, so I'm going to turn it into a mixed number. I have 1 whole times 12 equals 12. 20 minus 12 is 8. So this one is worth 1 whole and 8 twelfths. I have 6 twelfths plus 6 twelfths. That's an easy one. If you have half and a half added together, that makes 1 whole. So 6 twelfths plus 6 twelfths would be 12 twelfths, which is equal to having 1 whole. There's only one person who had 7 twelfths of their Hershey bar. And now I have 8 twelfths times 3. Eight times 3 is 24. 12 times 1 is 12. So 24 divided by 12 would equal 2 whole. 9 twelfths, there's only one person, so that one is 9 twelfths. And 11 twelfths, there's only one of those. So now I'm going to take all of these and add them together. It's probably helpful to do this on another sheet of paper so that you can see it a little easier. So I'm going to rewrite these. Okay, I'm going to add my whole numbers first. I have 1 whole, plus 1 whole makes 2, plus 1 more whole makes 3, plus 2 whole makes 5. So we have 5 whole. Now I'm going to add my fractions. Thankfully, all of these fractions already have the same denominator of 12. So now we just have to add the numerators. 1 plus 4 equals 5. 5 plus 6 equals 11. 11 plus 8 equals 19. 19 plus 7 equals 26. 26 plus 9 equals 35. And 35 plus 11 equals 46. This is definitely an improper fraction. So we're going to convert this improper fraction into a mixed number. 46 divided by 12. I know that 2 twelfths would be 24, 3 twelfths would be 36, and 4 twelfths would be 48. So I'm going to multiply by 3. 3 times 12 equals 36. I have 10 left over out of 12. So this is going to replace my improper fraction. So now I'll add my whole numbers with my new mixed number. 5 whole plus 3 whole equals 8 whole and 10 twelfths. So that is our final answer for question number 5. The whole class ate a total of 8 and 10 twelfths Hershey bars.